Hello, I'm Raghunath, the founder of Legacy Code HQ. We are a startup that is building this tool called AppSplitter. AppSplitter is a desktop developer tool for Android engineers. If you're an Android engineer and have access to a large monolithic Android code base, you can use AppSplitter to break it down into small modules. Today, in this video, we're going to look into Wikipedia's Android code base, and I'm going to show you how to use AppSplitter to prepare the logging layer for extraction. In terms of Wikipedia's Android code base itself, it has been around for quite some time now, and at this point, it's been there for almost 11 years. The code base has about 260,000 lines of code. To me, when we're talking about the code base in terms of lines of code, that falls somewhere between to a small to medium sized code base. And most production and proprietary code bases out there fall into this category. Although preparing a logging layer for extraction might seem like a straightforward process, I believe it's valuable for the following reasons. First, you don't really have to have a lot of context about the rest of the code base to understand what is going on. Second, it's a small layer that you can extract to see how AppSplitter's feature can help you in the decision-making process. Third, a lot of code bases out there do not have sufficient amount of tests. And even if they do, some parts of your code base are always going to be hard to test. If you're in a situation like this, the workflow that I'm going to demonstrate will help you make changes reliably and safely in the absence of tests. That being said, let's get started. This is the current home screen of the AppSplitter dev tool. We are going to prepare the logging layer for extraction. So I'm going to select the extract module screen. And now, when you're in extract new module, it's going to ask you for a class that you're trying to extract. I know there is a class called L. This is responsible for logging. So I'm going to pick that as the type that I want to extract. And I'm also going to give it a suitable module name. So we're going to call this logging, and I'm going to click on define boundaries. So this is the define boundary screen. And on the left of the screen, you're seeing a dependency graph on how the class L is related to other classes in the code base. And on the right side, you have a manifest that shows a list of immediate dependencies. So the header section is the class that we're trying to extract, and these are all the immediate dependencies of the class itself. Now that we have a list, we have to review each item on the list to make sure which classes will be part of the extracted module and which ones will not. The first one is the log level class, which is a nested type. So you could see l.log level. So that says it's a nested class inside the class L itself. And there are three buttons on the right. So the first one lets you see all the couplings between the classes. So when I click on this, you'll see how both of these classes are related to one another. So there are a bunch of property declarations, constructor invocations, and method calls that are happening between L and l.log level app. Since this is a nested type, I would want to make this as part of the extraction. So I'm going to say I want to include this as part of the extraction itself. And when you do that, you would see that there is a new item that appears on the list itself. And this one is going to list the dependencies of l.log level itself, right? And the second item is the release util itself. And I would want to decide whether to keep this class as part of the new module, or I want to break this dependency and not make it part of the new module. So again, we're going to inspect the couplings and then see how they are related to each other. So L is accessing a couple of properties inside the release util class itself. I would ideally go ahead and break the dependency because I don't really want release util to be part of the extraction. But let's see what happens when I try to include this dependency as part of the new module. So when I do that, again, you would see release util gets included as part of the new module, and then it also lists the dependencies of release util. And here I could just go ahead and then do include prefs. So at this point, you would see again, we have the prefs as part of the new list item, and then this is going to list all the dependencies of the prefs class itself, right? And when you interact with the list on the left, you also see that the graph changes on the left. At this point, when you're thinking about boundaries, one is you're deciding what dependencies or classes should be part of the new module and which one shouldn't be. And there's also another thing that I mentioned when it comes to defined boundaries is what is the responsibility of the class that you're trying to extract, right? In this case, logging and preferences are two different concerns, and there should not be a connection between the two, at least a direct connection between the two. So I would not want preferences to be part of the new module, right? But if I'm going to extract release util, then I might as well like extract prefs. So at this point, I know that release util should not be part of the extraction. So I'm going to mark this dependency as a dependency that should be broken, right? And now when you start looking at Wikipedia app and Wikipedia applet companion, these are Android application classes. And again, like these need not be part of the extracted module. So I'm going to mark these two classes as dependencies that needs to be broken as well. Now, let's look at the second class that is part of the new module, which is l.loglevel. And this one also relies on release util. So if I'm going to look at the coupling between log level and release util, you could see there is a property that is being accessed. And again, we don't really want release util to be part of the extraction. So I'm going to mark this dependency for breaking as well, right? So this is our plan for extracting the logging module. So we would only want these two classes to be part of the extracted module, and we don't really want these other classes to be part of the extracted module, right? And once you break the dependency, if you look at the graph, you would see those lines between these dependencies are marked in a dotted line. That means those are dependencies that are meant to be broken. So that's how we plan our dependencies. So in this screen, you notice that we are not only isolating the responsibility of the class, we are also isolating dependencies based on what concern we want to address, right? So this is done. Now, the next thing that we're supposed to do is go to the IDE and break this dependency, right? And this is part of the video that is super critical. And I think this is where you also would derive most of the value. Earlier in this video, I mentioned some of the code bases do not really have tests, or like some parts of your code base can be hard to write automated tests for. And in such scenarios, it can be scary to make changes to the code base, right? However, I would also want to point out that in the absence of tests, there are other things that you can rely on. First, if you're going to use the IDE's automated refactoring actions, those are like really tested and pretty solid, so they can make transformations that are really safe. When you're working with an IDE like IntelliJ, IDEA, or Android Studio, some of these transformations are like pretty powerful, and they can make changes that avoid breaking your code base itself, right? So IDE assisted refactoring is a powerful technique that you can rely on. Second, you have the compiler, and the Java and Kotlin compiler is quite powerful that they will help you prevent making mistakes when you're making certain changes to the code base itself, right? And the third thing that you can rely on is linters. In this example, we will not involve, like the transformations are not going to involve a linter, but linters are something that you can creatively rely on to make safe changes in the absence of tests. The fourth thing that I want to point out is your Git GUI client. If you're using a Git GUI client and not the Git command line, it's not very helpful, especially when you're refactoring. A Git GUI client can help you make changes that are pretty confident and do not break the code when you're making these transformations. And the last one I would rely on is the manual testing. In the absence of automated tests, it's your responsibility as a developer to manually test the thing that you're going to ship. It may seem obvious, but then there are like a little bit of nuance to it. I want to reiterate on this. In the absence of tests, you can rely on your IDE, you can rely on your compiler, you can rely on your linter, you can rely on a Git GUI client, and you could also rely on manual testing, and in the sequence from the most to the least reliable things, right? Now let's go to the IDE and then make this change, right? So before I go to the IDE, I would want to, I'm going to tell you what the plan is. The first thing is we're going to break the dependency on the release util class, and I'm going to click on this, Now I see it's coupled on line number 98 and 109. I'm going to note that down. So line number 98 and line number 109. And then I'm also going to look at the release util over here, and then it says it's coupled on line number 117. So first thing, the first order of business is to go to the IDE and break our reliance on release util, and you're going to see how this is going to look like. I'm going to switch to IDA Studio. First, we're going to go to this class called L, and let's go to line number 117 and see what's going on there, right? So here you have release util.isDevRelease. The first thing I'm going to do is I'm going to extract this as a function. So extract that as a function, and now it's going to tell me which target code block I have to extract this to, right? And you have two scopes. So it's interesting because one is local to the log level class itself, and the other one is like at a higher level. And especially when you're refactoring, if you have access to a higher level scope, always, like, it's not always, like most of the time it's a good idea to go to a higher level scope because you don't have to rely on other dependencies. So I'm going to pick this one and I'm going to call this X. So you don't really have to think about the name here. Just go ahead and give it a name, and you would understand why I did this like later in the video, but it's okay to give it a random name. And once we do this, the next thing I'm going to do is to go to my Git client, and then I'm going to mark this thing as a change, right? You would have noticed that we have used the GitHub, the IDE's refactoring action, and I've not made any changes by myself. Like I did not type into the IDE, I didn't do any of that stuff. So this is a thing that I'm going to commit. I'm going to say R, and then I'm going to call this as extract function, right? So that is done. So line number 117 is taken care of. Now the next thing that I'm going to do is going to go to line number 109 and then see what's going on here. We still have something very similar, accessing a property from the release util type. I'm going to extract this as another function. I'm just going to call this Y, and then go to the IDE and then mark this as extract function. Right, we're done. And then let's go to the next line, which is 98. And to see what's going on here, extract this as a function again. I'm going to call it C, right? That's all there is. So we have extracted three functions. That's all. We didn't do anything. Let's see what's going to happen next. All right. So now we have all of these things, and when you have three different functions, they have very similar pattern, right? So I'm going to put them together to really understand what is going on and see what the pattern looks like, right? So this is a manual change that I've made, and if you look at it, we have these three functions on the screen. And if you look at it, it's pretty similar, right? It's just accessing property. And even if you look at it, take a close look at the properties themselves, it says is dev release, is pre-beta release, and is prod release, right? It's probably trying to determine the kind of release that's happening, right? I'm just going to keep these here, and I'm going to look at the IDE, and you see it's a manual change. I did move these functions and then I put them together in a close proximity. And since this is a manual change, I'm going to use a slightly different notation for the commit message itself. I'm going to call this R followed by a double bang, and then move functions together. So even though it's a refactoring action and it did not break anything in the code because you're just like moving them to a different line number, I'm marking this with a double bang because that calls out that this change was not made using the IDE. And if someone is going to review your pull request, for instance, they could pay extra attention to make sure that you're like not making any mistake when you're making those changes, right? The next thing that I'm going to do is I want to break this reliance on release util, and these are the only things that we're dealing with right now, right? So if you want to break a dependency, then one of the things that we can do is probably introduce an interface for release util, right? And if you look at these three functions, we are only dealing with the type of the release. So I would want to create an interface called a release type that is going to address only these three concerns, right? I'm going to go to the release util class, and I'm still going to use the IDs refactoring here, and I'm going to say extract interface, right? And it's okay to just like keep it right here at the moment, like inside the same file. And I'm going to call this release type. So that's done. I'm going to go to the IDE, the Git GUI client again, and I'm going to stage this and then call it extract interface. So that's done. So let's go back. Now there's a new interface that's introduced. Now I'm going to go back to this property. The first property here is dev release, and then I'm going to use another IDE refactoring action. It's called pull members up, right? And I'm just going to pull this member up, and that's done. So I'm going to commit this change. I'm going to call it pull member up. And the next thing that we're going to do is go to the other property over here, and then I'm going to do the same thing. I'm going to pull this member up. Go ahead, commit this one, and then go back to the L class. And here I'm going to go do the same. I'm going to do Control T, pull member up again, and then commit the change. Right. So look at it, we now have a new interface with all these three things, and this is a good way for us to break the dependency between the class L and the release util itself, right? Let's go make a few more changes. The first thing that I'm going to do is now we have to get rid of release util. To get rid of release util, there are like a few more transformations that need to happen. So the first thing that I'm going to do is I'm going to extract this as a new variable. Since release util is a object, you can extract that as a variable without any problem. So I'm just going to extract this as a variable, and instead of calling it release util, I'm going to call this release type, right? So that was also a IDE transformation introducing a new variable. So you could just go ahead and then say R introduce variable. And then now that I did it, you still have to figure out what type this is, right? Because at this point, we're relying on the Kotlin compiler's type inference, and the type inference is going to pick release util as a type. But I would want to introduce a new type, which is the new interface that we have introduced, right? This is a manual change, and now I've specifically said the type of the variable is going to be release type instead of release util, right? I'm going to mark this as a change, but I'm going to add the double bang to make sure to call out that this was a manual change, that it was not an IDE refactoring. So this is going to be introduce, like specify type explicitly. So there we go. I'm going to do the same thing for the other two functions as well, like introduce this as a variable and then call this release type. This change was a IDE automated refactoring, so we could just say introduce variable. And the next thing I'm going to do is I'm going to call this release type. So that was a manual change. I have to copy this commit message over here, paste it. Same thing for this one as well. It's going to be release type. Sorry, release type. So that is going to be introduce variable, and I have to call this, sorry, release type. What went wrong? Interesting. Oh, sorry. So now I've made a mistake. I've extracted this entire thing as a variable instead of just release util, but that's okay because I can just go ahead and revert this change. And I can go back, drop this commit because this is not doing what it's meant to do. We should have extracted release util, but I extracted the entire property as a variable, so I'm just going to drop this. And one of the benefits of committing frequently and using micro commits is you don't really, you can just like revert back if you made a mistake. It's quite cheap to make mistakes and correct them. So now let's just, yeah, this one should work. That's done. So I have to call introduce variable. I have to make a review. Yeah, I'm just extracting release util instead of the entire statement. Now I could just call this release type. And then this is what I'm going to name the commit. All right. So this has been done. So now we have a bunch of methods that look very identical. The next thing that I'm going to do is I'm going to make this thing, I'm going to promote this to a property from a local variable, right? So when I do that, I could go ahead and then remove all of these things. So now we're relying on this interface called release type. And the release type is being replaced with release util everywhere else, right? So this is a manual transformation where I took a local variable and then promoted it to a property. That's okay, and I'm going to mark this as a manual change. Elevate local variable to property. So that's done. So this is a manual change, and if you look at this change, it looks very consistent. You see the same pattern showing up everywhere else in this change set. And if someone is going to review it, they can probably take a look at it and deduce if you made the right change or not, right? So that's done. The next thing that I'm going to do is you have to get rid of release util from this altogether and only rely on release type. So the next thing that I'm going to do is a little unconventional. So I'm going to make this a private, as a late init var, right? So now I've made this into a late init var, but I've also gotten rid of the release util reference from here. And if I do a optimize import, then it says one import removed, which means if you go look at the git commit, then you know that we've gotten rid of release util itself, right? So at this point, I'm not going to commit because I know I've broken this code and I can also verify it. And remember in the beginning of the video, I said there are 5 things that you can rely on. The last one being manually testing the code itself, right? And here is where the manual testing comes into play. If you are someone who is used to test-driven development, or if you write characterization tests for existing code, you know that the test should fail, right? And that's no different for manual testing as well. Because at this point, I want to make sure that I am making the right change. And for me to verify, the manual test that I'm going to do should fail, right? So in this case, since we no longer have access to release util, if I run the application, it's supposed to crash with the uninitialized property exception because this property is not being initialized at this point, right? And if my understanding of the code base is correct, launching the application in the emulator right now should cause a crash with uninitialized property exception. So I'm going to run this code and I'm going to wait for the emulator. Let's also open logcat. Let's wait for the application launch. The application launched, but also crashed. And if you notice, it says like late init property release type has not been initialized. So that's exactly the kind of exception that we're expecting. So this is good. So we know that we are trying to make the right kind of change and our manual test failed. Now, the second step is to go make it pass, right? So when you're trying to make this pass, the next thing I would do is I would probably go to the Wikipedia Android class, Wikipedia app class, and here inside the initializer, I would go ahead and say l.releaseType is equal to release util, right? And now since the property is initialized properly, if I launch the application right now, it should run without crashing. So we did a manual test which failed initially, but then now it passed, and now you can see the application on the emulator itself, right? At this point, I'll go to the code base, sorry, the Git GUI client, and then see we've removed release util from here, and then we've also initialized it properly, and then I did a manual test to verify that the application works properly. I have to mark this as a manual change. Sorry. Commit this with the initialize L from Wikipedia app. So at this point, we've broken the dependency between L and release util, right? The next thing that I'm going to do is go ahead and break the dependency between Wikipedia and Wikipedia companion. So here you could see we're dealing with line number 110, and here it's also line 110. So it's the same line. Let's go to line 110 and then see what's going on in the code base. Go to class L 110. So here is where we have Wikipedia app instance and log crash manually. I want to see what's going on with log crash manually, and then if you look at this one, so it's just accessing the log class again. So it's basically a cyclic dependency between the Wikipedia app class and the class L. At this point, I don't really have access to the engineers who are working on the code base, and to me, I would just go ahead and inline this class. So when you inline this, you're still keeping the comment, which can prove to be helpful if you decide to revisit this later on. Let's go ahead and then commit this change as well. So I've committed this change, and if you also notice the import statement, Wikipedia app is also no longer referenced inside the class. At this point, this is an IDE-driven refactoring, so I would just say inline function. At least if you start looking at the diff between these two commits, and if you look at the header section of the L class, you can see that we no longer have reference to Wikipedia app, and we no longer have access to the release util. So that is proof that we don't really have access to, we don't really have dependence on these two classes. You still see these small functions. I forgot about them. Let's go and deal with these things before we end this video. These functions are no longer necessary, right? So you could just go ahead and inline them. I'm going to go to the IDE again. And if at the bottom of the class, you see there's a function called X, I'm going to inline this. So that's an IDE-driven refactoring. Come back, stage this, and then say inline function, right? And then you have N, this one, inline that also. The last one, I'm also going to get rid of this new line, it's no longer needed. Yeah, that's done. Now, if you come back to App Splitter, you can see the dependency graph looks very different. And L now only depends on L.log level, which is basically the nested type itself. So we're going to include this as part of the new module. And then if you look at release type, this is a new type that we have introduced. So this looks good. I'm also going to make this part of the extracted class. And if you look at log level, it still depends on its enclosing class, and it also depends on release type. So I'm also going to include that as part of the extraction. Now that you can see, we don't no longer have any references to the release util or the Wikipedia. At this point is where we are supposed to go to the wizard, which is not part of the screen yet, but the wizard will give you detailed steps on how to extract this as a new module, right? So that's the demo. The few things that I want to touch upon again. App Splitter is a tool that can help you modularize your Android code bases. And this feature, the define boundaries feature, is still under development. Everything that you're looking at is basically still being worked upon. So the final product may look very different from what you're looking at the screen right now. And the last and the most important takeaway for you from this video is when you don't really have tests, you can rely on your IDE, you can rely on your compiler, your linter, your Git GUI client, and also a little bit of manual testing to make changes safely and ship code to production. And the workflow that I showed you is something that we use when you're working with other code bases, especially code bases that you're not familiar with. And it has a pretty high success rate if you follow the process, and you can make really make safe structural changes when you don't really have tests. With that being said, I'm not saying you should not write tests. Like, tests are something that we are very important and like is a very reliable safety net when you're making large changes to code bases. But sometimes we are under constraints where we don't have that safety, and you can leverage other things to safely make these changes. And that's all. I don't have anything else to add. If you are interested in Apps Twitter, you can find a link to one of our early access program forms. You could just go fill it, and whenever the product is ready, I would share it with you. And if you have any questions or comments, feel free to post them in the comment section. I'm always happy to hear it from you folks. Thank you, and thank you for watching.